Welcome to IEEE OES short-term course on AUV Modeling. I am Mohammad Ibrahim, a BTech from IIT Madras. Today I will be taking you through the electronics module of the session. Without further ado, let's start with the session. So let's first discuss the content of today's presentation. Initially, we will be talking about the general robotics module. Then we will be talking about the general robotics setup. Then we will come to the main topic of today, that is the electronic module. And then we will discuss one of the main aspect, main component, main part of the electronic module, that is the powertrain. Then I will also show you some of the basic robotic sensors. And finally, from the knowledge that we have gained throughout the course, we will try to implement and design a electronic setup with proper powertrain and signal transmission for an AUV. So let's first start with the general robotics module. So there are mainly three modules in the robotics domain, mainly mechanical module, electric module and software module. The mechanical module mainly comprises of the physical structure, the propulsion and the mobility. It's mainly task specific. If you want to do some specific task, the mechanical module will change. It varies with the domain. For example, aerial robotics have different kind of mechanical system, underwater robotics have different kind of robotic mechanical system, and ground vehicle have different kind of robotic system. Then we have electrical module. Electrical module mainly comprises of the power management, the sensor interface as well as the actuator command. Then we have software module. Software module mainly comprises of the decision making algorithms, autonomy algorithms that will take the input from sensors and do decision making and do processing the data, and finally it will pass the final actuator commands. So one key note we have to keep here is the mechanical module have a significant effect on designing the electrical as well as software module. For example, the software must adapt the mechanical limitations. For example, the thruster configuration, if you want to move in some more degrees of freedom, but if thruster doesn't have that, there's a limitation there. So you have to take in account in your software module. Next, let's see the general robot setup. What's the main idea of a robot? So you can think a robot as similar to human. So for us, similar to us, we have sensory organs, same as a robot has sensors to perceive its environment. Then you have processing unit like our brain to process the data from our sensory organs and do necessary actions. Then you have controllers, which you can think similar to our nervous system. Then finally you have actuators, which is our more similar to the muscles. So let's consider this box as a robot. So you have sensors which will connect information from the environment and it will pass to the robot. Then finally you have actuators, and the robot should take the data from the sensors, and finally it should be able to give some signal to the actuators to make the actuator move. So this will take action to move in the environment. So the entire setup, that is from collecting data through the sensor and passing that to the actuator to take action, comprises the entire robotic setup. So all the modules, all the setup that we be covering throughout the session will be mainly focusing on the middleware, how it will be getting from the sensor and to transmit to the final actuator. So let's see what comprises in this part. We don't know what all comprises in this part. Let's see what mainly comprises in this part. So here you can see, apart from the sensor, there are two more inputs to the robot. They are fail-safe mechanisms and encoder inputs. So sensor inputs, as we thought, it will perceive the environment and give necessary sensor environmental informations. Encoders are also similar to sensors, but they keep a track of the actuators if they are actually following your actuator commands. For example, if you are telling your servo motor to move in some degree, let's say 35 degree, and you don't know actually whether the servo motor has actually moved 35 degree. So this encoder will keep in track of the actuator and it will feed back this information to your controller so that you can have a better control of your robot. Then fail-safe mechanisms are mainly because when you a robot goes out of control, the fail-safe mechanism help in to get back the control of your robot. Then as we discussed before, what all comes inside the robot, comes inside the processing as well as the main part of the robot. Here we have processors like our brains, which will process the data from the sensors. Then it will pass that to your microcontrollers, and the microcontroller will send PWM values back to your actuators. Then you have also separate section called Powertrain, which basically handles the power distributions. So here we will be discussing much further in detail about the powertrain in the later slide. Yeah, so let's since we have had a glimpse of the general robotics setup as well as the modules in robotics, let's now focus on the today's main topic, and electronic module. So the electronic module mainly comprises of sensors, actuators, fail-safe mechanism, processors, and powertrain. So this electrical module is so important that it should facilitate the transfer of data from the sensors, and finally it should process with the help of processors and controllers, and finally the signal actuator commands should be passed down to the actuators. So it facilitates the entire setup. So let's see what are the main components of electronics module. On the left you can see one of the main part of electronic module is powertrain, which delivers power to different components. We'll talk much in detail about the powertrain in the later slide. Then you have sensors, fail-safe mechanism as we discussed before, actuators, processors, and controllers. So these 6 components are the basic stones of electronics module. Now let's discuss powertrain in setup in detail. So powertrain, as I said before, ensures the power distribution across your sensors as well as actuators as well as encoders. So one of the key importance of powertrain, for example, let's say in our building in AUV case, the AUV, one of the main feature of an AUV is its endurance. So designing an efficient powertrain is so important that will help in improving your endurance of your AUV. So let's discuss what are the main components of powertrain. So powertrain will have basic or primary battery source, which will have some voltage V, let's say. Then you have buck boost converters, which are act as step down or step up transformers, which will change from one voltage to higher voltage or lower voltage. Then you have power distribution boards, which is mainly to distribute the power across various sensors. Then you have battery management system. This in case of AUV is very important because you are deploying the battery underwater. So there should be proper battery management for your to take care of the health of your battery. Then you have processors and controllers on the board.